Okay, look at this chapter, refraction. Okay, this is the chapter of unit 6, that's mean optics, and chapter 2, okay, refraction on plane surface. Okay, listen, actually I am preparing this video for the school as well as my English medium batch and my Bengali medium batch. Okay, whatever, so sometimes I shall use some Bengali terminology. Okay, whatever, so let's start. First of all, refraction in Bengali we shall call it as protisharon. Okay, so what is this refraction is actually? Let's say this is a medium. Here this is medium 1, here the medium is here, this is medium 1 and this is medium 2. Okay, let's say the refractive index of medium 1 is mu1. I'm not giving a detailed conception about the refractive index because it is already from the previous classes from class 10, and this is another one with refractive index mu2, and we are taking mu2 is greater than mu1. That's mean mu2 is the denser medium, means ghano madhyam, and mu1 is the rarer medium, means laghu madhyam. Okay, and if a ray of light is incident here, it come closer to the normal, মানে অভিলম্বের দিকে সরে আসে, it come closer to the normal, and if the angle of incident is I and angle of refraction is R, then we can write sin I by sin R equal to mu. Now the question is sin I by sin R equal to mu, but I was just written here mu1 and mu2. So how the equation we can write here? Actually this is Snell's law, we all know it, Snell's Sutra. Now we can write from here the general form of Snell's law, that is mu1 sin I equal to mu2 sin R. What is the speciality of this equation? Just look at this. When I am taking the sine of the angle of first medium, that's mean this one, then I am taking the refractive index of the first medium. So the total matter of the first medium is together and the total matter of the second medium is together. মানে দেখ, যখন প্রথমটার প্রতিসরাঙ্ক নিচ্ছি তখন প্রথমটারই কোণ নিচ্ছি, যখন দ্বিতীয়টার প্রতিসরাঙ্ক নিচ্ছি তখন দ্বিতীয়টারই কোণ নিচ্ছি। ওকে, সো এইভাবে আমরা খুব ইজিলি মনে রাখতে পারি। দিস ইজ আ ওয়ে। ওকে, নাও হোয়েন ইউ রাইট সাইন আই বাই সাইন আর, sin I by sin R, then you will find this is mu2 by mu1, this is mu2 by mu1. Okay, and from here we can write mu2 by mu1 equal to 1 mu2. This means the refractive index of the second medium with respect to the first one, প্রথম মাধ্যমের সাপেক্ষে দ্বিতীয় মাধ্যমের প্রতিসরাঙ্ক, the refractive index of the second medium with respect to the first one. So I can write it as 1 mu2. So this is the way, and this is the general form of Snell's law, general form বা সাধারণ রূপ, general form of Snell's law. Okay, now what is this refractive index? Actually basically we have the formula mu equal to c by v, where c is the velocity of light in vacuum বা শূন্য মাধ্যমে আলোর বেগ, and v is the velocity of the light at any medium, and mu is the refractive index of that medium. Mu equal to c by v, so I can write mu1 equal to c by v1, as well as I can write mu2 equal to c by v2, mu2 equal to c by v2. So from here I can write 1 mu2, that is equal to mu2 by mu1. Okay, be careful, 1 mu2, but at first here 2 and then 1. Okay, that is equal to mu2 equal to c by v2, and mu1 equal to v1 by c. So that is equal to v1 by v2. So 1 mu2 equal to v1 by v2. Is it clear? You have to remember this formula as well as this formula also, and this one, 1 mu2 equal to v1 by v2, sorry, v1 by v2. Is it clear? You have to remember this. Okay, now look at this. We have a formula v equal to n lambda. This is from class 11, from chapter sound. Velocity, that is equal to frequency into wavelength. Velocity equal to কম্পাঙ্ক into তরঙ্গ দৈর্ঘ্য. Okay, velocity equal to frequency into wavelength. So from here we can write v1 equal to n lambda 1 and v2 equal to n lambda 2. You may ask me why it is not n1 and n2. Basically, when a ray of light enters from one medium to another medium, its frequency never changes. Its frequency remain constant. That is why this is n and this is also n. Now we can cut out this n and it will become lambda 1 by lambda 2. So I am getting another relation from here. 1 mu 2 equal to mu 2 by mu 1 equal to lambda 1 by lambda 2. Okay, so from here we can write 1 mu 2 equal to lambda 1 by lambda 2. Keep this in mind. These formulas are important for MCQs. Okay, and beside that we need this formula in various aspects. Okay, whatever. So these formulas are important here actually. Okay, so you will find it in your book. Okay, so now another relation, mu equal to a plus b by lambda square. Actually this is the relation between refractive index and the wavelength of light in a particular medium, and this is another equation, mu equal to a plus b by lambda square. This is not like that there are a lot of terms c by lambda cube plus d by lambda to the power 4 like this, but we can ignore these terms. Okay, though we this is not an important equation for our classes. Okay, but this equation is known as the Cauchy's equation, Cauchy, Cauchy's equation. This equation is known as the Cauchy's equation. So of course someone may ask you what is Cauchy's equation or write Cauchy's equation, where a and b are the virial coefficient or some arbitrary constant. Okay, now if you plot a graph with refractive index and the wavelength of light, let's say refractive index and the wavelength of light in micrometer, of course the graph will be like this. Okay, so next little bit common phenomena we shall discuss here. This is a medium. Okay, this is mu1 and this is mu2. A ray of light is incident here perpendicularly, and we know it will not change its path. Okay, so here the angle of incident 90 degree. No, here the angle of incident is 0 degree, as well as the angle of refraction, that is also 0 degree. Okay, be careful, this is the normal incident, lombo apaton. Okay, now deviation of light. So in Bengali alokroshir chuti. Okay, so let's say this is the normal, this is let's say mu1 and mu2, and what I am doing, just I am drawing a ray of light, and the ray of light changing its path like this. Okay, if the medium isn't here, so the light can go along this path. So alo ei soja pathe chole jeto, but just look at this, the light deviated from its path. Let's say this is I1, let's say this is I and this is R. Okay, so the light deviates from its path and deviated by an angle delta. So this angle delta is known as the angle of deviation. This delta is known as the angle of deviation. Okay, so this is angle of deviation. This is the angle of deviation. So how this to calculate? Very easy. Look at this, if this is I, then this is also I, opposite angle or biprotip kon. This is I, this is also I. Okay, so delta equal to basically I minus R. Okay, delta equal to I minus R. If you can't understand, just think twice, you will find yourself. Okay, and this is a topic from class 10. Okay, there are another consequence. Let's say another ray of light is incident here and it is passing like this. Okay, so if the medium is not here, the light can go along this path. So this is I, so here this is delta and this is R here. Okay, so here basically delta equal to I minus R. Okay, so whatever, just check the book, this is a very easy consequence. Okay, okay, so look at the next video.